Welcome everyone to another lecture on the topic of limit computation. Uh, this time we want to talk about a new technique of factoring. It's called factoring technique. And in this technique, just like any other method, the very first thing you do is trying to see if the limit can easily be found by direct substitution method or not. But the thing is that here, when you want to find the limit of this rational function, when you plug in 3 in the numerator, you get 9 plus 3, which is 12, minus 12, that's 0. So we end up with 0 in the numerator. And when you plug it in the denominator, you get 9 minus 7 times 3, 21, which is negative 12, plus 12, that is again 0. So we end up with 0 over 0, which is, of course, indeterminate form, right? So we see that direct substitution method doesn't work. It doesn't give us the answer easily. So what we're going to do, we're going to use this technique of factoring. And as the name clearly states, we are going to try to factor the numerator and the denominator. The numerator can be factored. It's a quadratic trinomial by the sum and product method studied in grade 10. So it's going to be x plus 4 and x minus 3. The sum is 1, the product is negative 12, so we factor the numerator. And the denominator can also be factored as x minus 4 times x minus 3, because two numbers add up to negative 7, but the product of 12 are negative 3 and negative 4 clearly. Now, when you factor the top and bottom, you see that there is a common factor of x minus 3, which you can simplify. So these two cancel out each other. And what is left over is only x plus 4 and x minus 4 in the bottom. So this time, for the second time in a row, we are going to try our luck to see if we can use direct substitution method this time after simplifying or not. So this time, when you plug in 3, you get 7 in the top and you get negative 1 in the bottom. And that means that the limit of the function is actually negative 7. And this time we see that direct substitution method works. So this technique that we use, like we use factoring, is called factoring technique. Okay. Another one here, it says limit of t cubed plus 1 over t plus 1. T approaches negative 1. If you try direct substitution method, the numerator will approach 0. The denominator also approaches 0. So this is once again 0 over 0, which is indeterminate form. So what we're going to do, we're going to try to factor the top, but this time we use a different technique of factoring. You have to be very, very fluent in different techniques of factoring from junior grades. This is sum of cubes, actually. So it's like a cubed plus b cubed, which is a plus b times a squared minus ab plus b squared. So this would be like t plus 1 times t squared minus t plus 1. And then the bottom would be just t plus 1. And t approaches negative 1. And we see that from the top and bottom, again, we have a common factor of t plus 1, which would be canceled. So we would be left over with the limit of t squared minus t plus 1 when t approaches negative 1. So now we try to see if the direct substitution method would work this time. And we end up with 1, and then plug in negative 1, you get 1 and 1. So the answer is, of course, 3. So limit of that function, t cubed plus 1 all over t plus 1, when t approaches negative 1 is equal to 3. There's another example here. The top is a quartic polynomial. The bottom is a quadratic trinomial. So I always try the direct substitution method, because sometimes you never know, it may work. And if it works, then it's going to save you a lot of time. If you plug in 1, you get 0 over 0. So we see that there is a need to use another technique. The bottom is a difference of squares, needless to say. Anybody knows that. You can factor the denominator. But in the numerator, you can factor x cubed out from the first two terms, and you can just factor 1 from the last two terms. And this way, you can actually factor x minus 1, which is the GCF between the two big terms in the numerator. So you get x cubed plus 1 times x minus 1. And of course, I'm not saying you can't use the factor theorem or other techniques of factoring, but if it can be factored in an easy way, why not? The first two have x cubed as a common factor. The last two terms have 1 as a common factor. So when you factor them out, you end up with x minus 1, which itself is a greatest common factor. So now we see that x minus 1 from top and bottom cancel out each other. So we get limit of x cubed plus 1 over x plus 1 when x approaches 1. So the denominator will approach 2 if you apply the direct substitution method. The numerator also approaches 2 because 1 cubed is, of course, 1, and then plus 1 is 2. And 2 over 2 is, of course, 1. So the limit of this big rational function, which used to be indeterminate form, now we know that it is equal to 1. The limit is equal to 1. Another question here, it says find the limit of this function. When you plug in 4, you will end up with 0 over 0. You can verify this easily using a calculator. Now the numerator is a cubic polynomial, okay? And we need to use a factor theorem extended actually. And we need to factor the numerator. The denominator is not that difficult to factor. It's x minus 4 times x plus 4 because it's a clear difference of squares. But the numerator, you need to use all those techniques of factoring and all the things you learned about remainder theorem, factor theorem in the past courses, and then you can factor the numerator. This is a calculus course, so it's not like an elementary basic level kind of course, and it requires a lot of previous math knowledge, a lot of things that you already need to know to tackle this kind of a course. So I'm going to write the answer. The answer would be x minus 4 times x plus 3 and times 2x minus 1. So the numerator can be factored using other techniques I've taught in the past courses. You already know factor theorem or whatever method. And the outcome, the final answer, is what I wrote in the numerator. Now, mind you, to get this answer, you may need to write one whole page. One whole page, you have to write to be able to factor the numerator. But that is not our discussion here. We're talking about limits here. We're not talking about how to factor a polynomial. That was in the past old courses, okay? So this is the final answer for the numerator. And again, we see that x minus 4 is a common factor. We can simplify. So x plus 3 times 2x minus 1 is left over in the numerator, and what is left in the denominator is only x plus 4. Here, let me use the calculator to make sure that the numerator is 0. So 2 times 4 to the exponent of 3 minus 3 times 16 minus 23 times 4 plus 12 is equal to 0. That's right. Okay. So now, everything is fine. We cancel out x minus 4 from top and bottom. So now the denominator is going to approach 4 plus 4, which is like 8. The numerator is going to approach 7, and then this one will be 8 minus 1, which is 7. So 7 times 7 is 49. So basically, the final answer will be 49 over 8. So limit of this giant rational function, where the numerator is a cubic polynomial, the denominator is a quadratic polynomial, when x approaches 4, is equal to 49 over 8. That's the answer to the limit. And the technique that we used is called the factoring technique. Okay, I gave you 4 examples, but you need to try maybe 40 questions, or maybe you have to do 40 examples to become extremely fluent in this topic of factoring technique. Okay, I hope you understood how this method works. I'm going to teach you many other techniques in future. Thank you for your attention and keep practicing.